Okay, this is section 1.4, equations and inequalities. And tonight we're not going to focus so much on solving equations and inequalities. We'll definitely get into that. But the majority of this will be just checking to see whether or not something is a solution to an equation or an inequality. All right, so let's start with some quick definitions. Remember, an equation is different from an expression. An equation is actually formed when you set one expression equal to another expression. So you have two expressions with an equal sign in the middle. And that equal sign is a really important part of the anatomy for the equation. It's necessary. It's got to be there. The solution of the equation is the number that you can plug in for x, and it makes the statement true. Okay, so whatever number can be plugged in for the variable, if it makes a true statement, then it is a solution. If it makes a false statement, then it is not a solution. And so let's take a quick look at what we're talking about here. Here's an example of an equation. 3x plus 1 equals 7. Notice that we have two expressions. So 3x plus 1 is our expression on the left-hand side. 7 all by itself is our expression on the right-hand side, and they are separated by that equal sign. Okay, it says check to see if the numbers 2 and 3 are solutions to the equation. So you can do these individually, and you can do this mentally if you wish. Go ahead and plug in a 2 for the variable and see if it is a solution. All right, so yes or no? Well, if you plug in a 2, it should work out. Remember, when you plug in your 2, you're going to plug in inside parentheses. So 3 times 2 plus 1 has some kind of relationship to 7. Well, 3 times 2 is 6, and 6 plus 1 is 7. And 7 on the left equals 7 on the right. Therefore, 2 is a solution. Okay, go ahead and try it with 3. When you try it with 3, you're not going to get a true statement. Okay, you'll see that when you plug in the 3, 3 times 3 is 9, 9 plus 1 is 10, and 10 does not equal 7. So it would say 3 is not a solution. And that's it. To test whether or not something is a solution, just plug it in. If you get a true statement, it is. If you get a false statement, it's not. So that's going to be one aspect of the assignment. The other aspect of the assignment, or one of the other aspects, is just beginning to do some algebraic translation. And we'll get into this deeper with the next lesson. Okay, but we're talking about translating algebraic expressions and equations into English, basically. So if you look at number 1, it says x plus 2 equals 6. That's how we'd say it mathematically, but you can also think of this as what number plus 2 is 6. Or even better, the sum of a number and 2 is 6. Okay, for the next one, 2 times a number is 10, or what times 2 is 10. And then for that last one, a number divided by 3 is 5. Or if you wanted to be fancier, you could say the quotient of a number and 3 is 5. Or back up there on number 2, you could say the product of 2 and a number is 10. The main thing I want to point out here is that in each of these we have an equation because we have an equal sign in each one. And what do you think that equal sign translates to? Well, for each one of these we translated that equal sign to the word is. Okay, so the equal sign we will always translate to is when we're doing some algebraic translations. Of course, this isn't going to be confined to equations. We're also going to be dealing with inequalities. And hopefully you remember your inequality symbols from middle school. And you have to have these memorized. Okay, so we have is less than or equal to, is greater than, and is greater than or equal to. And you'll notice that I pronounced those slightly differently than how they popped up. To be grammatically correct, we do have to throw in a verb in front of here. If we don't throw in the verb is, less than by itself actually implies subtraction. Like if I say 2 less than 10, that means 10 minus 2. We're talking about the number 8. But if I say is less than, I'm talking about the inequality symbol right there. So let me go ahead and fix these. Is less than or equal to, is greater than or equal to. These are all verbs, okay? Just like the equal sign is a verb. And you do have to memorize these. I know that some of you guys back in 3rd, 4th grade, whenever you started doing inequalities, maybe you talked about alligators and Pac-Mans and, you know, eating the bigger number. But in algebra, when we're dealing with variables, okay, you have to be able to look at this and read it correctly. I don't want you to look at something like this and say, well, the y must be the bigger number because it's being eaten by the alligator, right? This is x is less than y. You have to memorize that that symbol does stand for is less than. And the trick that I usually use is I think of the letter L for less, and this symbol right here kind of looks like an L turned over on its side. And that's the way I always distinguish between that one and the is greater than symbol. Also notice the ones that have is less than or equal to or is greater than or equal to, those contain half of an equal sign. Okay, and that means you can be equal to the number or above it or below it depending on the symbol. So let's take a look at some of these examples. So you're also going to have to determine whether or not something is a solution to an inequality. And this is a blue example, so you need to go ahead and get out paper and pencil if you haven't done so already. This will be what you're turning into me. But it says decide whether 3 is a solution for the following inequalities. The thing about the inequalities is they often have more than one number as a solution. Okay, so 3 might not be the only solution we're talking about here, but it could be one of a set of solutions. So I'm going to go ahead and throw 4 of these up here. You'll want to copy them down, and then you're going to decide whether 3 is a solution by plugging in 3 to each of these. See what pops out. If it's a true statement, then it is a solution. If it's a false statement, then it's not a solution. And you can go ahead and write yes or no for each of these after you've done the work. So go ahead and do these on your own and hit pause now, and then we can reconvene to go over answers. All right, let's see what you came up with. On this first one, it says 3 times a number minus 2 is greater than 5. And we're going to be plugging in 3 for x. And so you want to be very organized and line up your symbols. Here we have 3 times 3 is 9. So 9 minus 2 is greater than 5. We know that 9 minus 2 is 7. So basically, you're just asking yourself, is 7 greater than 5? That is a true statement. If it's a true statement, then it is a solution. So we will write yes for this one. Down below we have x plus 5 is less than 8. I'm going to plug in the 3 for the x. 3 plus 5 is less than 8. And we get 8 is less than 8. So what do you think? Is 8 less than 8? That's a false statement. So I have to write no. It is not a solution. Okay, back up top, 3 minus 1 is greater than or equal to 2. 3 minus 1 is 2. 2 is greater than or equal to 2. This one's a little bit trickier, okay? Is 2 greater than 2? No. But is 2 equal to 2? Yes. And since it's an either-or statement, it only has to satisfy one of those conditions. So 2 is equal to 2. 2 is equal to 2, so we can work with that. So I'm getting back here. 2 is greater than or equal to 2. That is true. So we'll go with yes. Apologize, hit something on my screen. All right, last one. Plugging in 3 for the x. Hopefully you did this one right. You could have gotten this one correct for the wrong reasons, but let's hope that you did it for the right reasons. Remember, we always plug in inside parentheses. Now what are you going to do first? You're going to do 4 times 3 is 12, or you're going to do 3 squared is 9. If you did 4 times 3 is 12, you get 12 squared is 144. That's incorrect. Okay, you have to follow the order of operations. You have to do the exponents first. So 3 squared is 9. So this becomes 4 times 9 is less than or equal to 32. And 4 times 9 is 36. Is 36 less than or equal to 32? That's a no on both accounts. So no, it is not a solution. So summing up, 3 was a solution for the first one, and the third one we did, but not the second and the fourth one we did. Okay, so that's it for your homework and the assignment for this lesson. You're just going to be testing whether or not numbers are solutions for equations, and then whether or not numbers are solutions for inequalities, and doing a little bit of basic translation. Good luck.